Okay, so today we're just going to do a little review of yesterday's quadratics and their shape called a parabola, and then we're going to do a um, a little assignment on Desmos. So Desmos is really cool because um, you can see the graph really easily. All right, so I have an XY uh, axis, and I put the x really low because most parabolas go down. Okay, so let's come up with.
We can't see the notes.
Oh, thank you. I appreciate that. Let me. I was working on the microphone so hard I forgot to press this button. Give me a second. All right. All right. Now you can see it, right? There it is. Cool. Sorry. Thank you for letting me know. Okay. So let's do a quadratic. What's the most simple, basic quadratic you have that you guys know or starting to know?
Did you get a chance to send the pictures of his work from me?
So which is the most basic one you know?
What do you mean?
So there are functions, right? Like for example, this is a function, but that's not a quadratic. Here's a function, but this is also not a quadratic. Square root of x. Here's a function, and this is also not a quadratic. Let me see. X times 3. I don't know. So which or I'll give you another one, and you guys could tell me which one is a quadratic. All right, which one of these four is a quadratic?
The last one. Or here you.
Yeah, the last one, which is I, right? I of x. So yeah, this one right here is a linear. It does a line, right? And this one, I'm going to just show you what it does. It does this weird like shape like that. And this one also does a line. And this one, when you have x times another x, that's a quadratic. That's a quadratic. And this one makes the parabola shape. So the simplest quadratic is x times x, right? Or you could say x squared, right? So you choose the one you prefer, whether you want to say x squared or x times x. I like x times x because I make less mistakes that way. Okay? When you put x squared, sometimes people multiply it by 2. So, all right. So the shape of this quadratic, the way you find the shape is you make a table with inputs and outputs. So the input, I usually start with 5, output 5 times 5, which is 25. So this coordinate will be 5 comma 25. And then I go down the list. 4. This like I said, this is a review from yesterday. Okay. This will be input, output. 3. I did it in my head. Is that okay with you guys? 2, 4, 1, 1, 1, 0, 0, 0. All right, so if you graph this, it's going to be right here, 3, 9. It's going to go up really fast, right? It went up. So 1, 2, 3, 4, 5. Oh, this is going to go really fast. Oops, I think I missed one. I missed 4. I shouldn't go up that fast. 2, 4. 2, 4, and then 3, 9. And then there was the negative versions of these. So imagine the table. Negative 1, negative 2, negative 3, negative 4, negative 5. So this would be negative 1 times negative 1, negative 2 times negative 2, which equals 1, equals 4, equals 9, equals 16, equals 25. So the negative version, I'm going to pick just a different color. I'm going to put these in green. And they'll be on this side of the parabola, of the graph. And there are millions and millions and millions of points that you could do. And this is how you represent millions and millions of points, by connecting them. Remember, it's kind of smooth down here, and we'll talk about that later. And then here is my parabola. All right, so it's just a little review, because obviously we're not going to have you guys grasp easy stuff like this, but guess what? They're all this easy, okay, even though they look hard. All right, and here, the lowest point is called what was the lowest point again, class, called?
The vertex.
Thank you. Yeah, everybody shout it out. Thank you. Vertex. And for this case, for this parabola, the vertex is also the y-intercept. Do you see that? Just for this case, intercept. And by pure coincidence, it's also the x-intercept for this parabola only. Okay. So that vertex is pretty much everything, right? That point, it hits the x-axis at 0, it hits the y-axis at 0, and it's also the lowest point. And then your axis of symmetry, I'm going to pick, yesterday we did it in yellow, so I'll stay with that. The axis of symmetry is literally on the y-axis. This is the axis of symmetry. Okay.
Could you write that a little darker?
Yeah, definitely. Okay. Let me pick this orangey color. This is the axis of symmetry. By the way, the axis of symmetry is always on the vertex. Would you guys agree that the middle has to be always on the vertex? On the vertex. Well, it crosses the vertex, so it hits it right there. Okay. So the axis of symmetry is okay. All right, cool. So I think that was pretty much everything that we covered yesterday. Okay. So now we're ready to level up, right? Like that song, level up, level up. I think it goes like that. I'm not sure. Okay. By the way, how many shapes of parabolas do you think there are? All right, here's one. Here's another one. Here's another one. Here is another one. Here's another one. How many shapes of these parabolas do you think there are, guys? What do you think?
Wait, I'm confused.
Yeah, so the question is, right here I have 1, 2, 3, 4, 5 different parabolas. You guys agree? The green one, the blue, the black, the purple, the red one. How many shapes do you think there are?
One of the same shape? Like, what do you mean by shape?
Yeah, they're exactly. That's kind of a trick question. They're all the same shape. Some are just narrow, some are tall, some are wider, some are upside down, some are thinner, but they're really all the same shape. if I were to zoom in on any of these, they will all be the same exact parabola. Watch this. So see this, the green one? The green one looks pretty skinny, right? But if I zoom in enough, it'll look exactly like every other parabola. Does that make sense? So every parabola is the same shape. It's just we're either zooming in or zooming out, okay? So typically I would do this on the whiteboard. I would draw a parabola and then I would zoom in and then I would make every single parabola. Like I'll make one really, really, really skinny. Watch this. If I'm going to put 100 times xx, and this is the little red one. See, it's really skinny. But if I zoom in enough, what happens to the shape of it? Yeah, it's exactly the same shape as all the rest of them. Okay. All right. So let's get down to what I wanted to talk about here. Okay. And ask questions, guys, because this actually makes this better, and also it helps me to hear what you guys are thinking. All right. So I'm going to do this. Don't click on this yet, but just follow me here, and then you'll understand what to do. And I'll guide you guys through it as you're doing it by yourself. Okay. But don't click on it yet. When you do click on it, you're going to join and then use Google, because that's going to keep your work. And then I'll be able to give you your score from your work. So remember, sign in with Google, okay? All right, mine was already signed in, so that's why it didn't ask me. Okay, so your first screen is going to be to evaluate the function for the following inputs. And the inputs are f of x equals x times x. So we actually did this work earlier. So you're going to put 16, 9, 4, 1, 0, and then -1 times -1 is 1, 4, and then 9. And then I want you to go ahead and plot it out here. So everybody go ahead and log in to this Desmos activity. And if you want, I'll put it here too. And go ahead and do the first page only, okay? And I'll be with you while you do that. So click on Desmos activity, log in with Google. Remember, log in with Google, and then just sign in. And let me find mine. I think it was this one. You hear my wife teaching her students. I think I lost it. Oh, this one right here. Okay, so this should be your first one. Go ahead and try it out, and then ask me if you need any help. Okay, and then you're going to plot out the points. 1, 2, 4. Kind of cool, actually. Since you don't have graph paper, I made this up this morning for you. 4, 16. And you could actually do all the way to 5 squared, which is 25. I'm going to do the right side in blue, and I'm going to do the left side in red, just for fun. All right, so give me a shout out if you guys are doing it. Just let me know that you are trying it out.
We have to write this down.
No. So what you do? You're going to do this on the on your computer. Thank you, Sarah. Raven. So yeah, try it on your computer. So I made this so that you don't have to have graph paper, and it's actually pretty cool because I can change the. So imagine you were doing it on paper, but so when you're done with page 1, just let me know, and then connect. And it's going to be tricky to connect this smooth because it's computer, but just try to. I think you can use your. I think it might be touchscreen too, and it's totally okay if it looks messy. Okay, and then go ahead and put arrows when you're done, like that. That tells me that they go forever. I'm gonna log into my teacher, and I can actually see what you guys are doing. So let me do that. And if you're stuck with anything, let me know. I can totally help out.
So circle A.
Let's see. Okay, I think the one I assigned you guys was this one.
How do we get there?
Oh, how do you get? So go to the pace, and I put a link right here. Desmos activity, and then log in with Google. Google. Okay. And let's see. I'm gonna go to my this one, and then I actually can see who's on and what you're doing directly. Okay. So I can see Hannah. I can see Nathan's on the second one. Okay. I see you, Leah. You're on it. Okay. So when you're done, I actually can overlap, and I can show everybody's work. See, Hannah did the red and blue. Okay. Kennedy, can you look at your data? Because I don't think you're going up enough. Remember, if these were steps, each step is getting taller and taller. And I think these steps aren't getting taller and taller. Okay. And unless you're zoomed in or something, let me click on yours. I can show you. Never mind. Look, actually, yeah, I guess it's okay. Yeah, never mind. It's fine. Okay, maybe it's just from the zoomed in. This one looks better. Okay, Sophia. Okay, and then Claudia. Make sure to put the points right, so they attach 1 1. Yeah, that's pretty good. Okay, and then we have the data on the side. Okay, and actually, I can overlap everybody's. So I can do a mashup of your guys' work. And if I did a mashup, look, check this out. Here's everybody's work. So I can see that whoever did the skinny red one is not right. So I can kind of help you out a little bit. Let's find out who did that one. All right. So Miguel, what? That's me? What? How? What? Are you serious? Oh, okay. So anyway, I feel burned. I actually did the wrong things. I didn't do the scale property. I thought each one of these is one. So, oops. So good job, everybody else except me. My bad. All right. All right. So let's go to the. Let me erase this. I feel embarrassed. Okay. All right. So I got to pay attention, like you guys did, to the. This is 1 1. Wait. Yeah. Tricked me. All right. Anyway. All right. Let's go to the second one. The second one's going to get a little bit more complicated. So the second one, we're going to, I actually drew the parabola for you. So go ahead and go to the second one. And your job is to find the numbers, okay? So from 0, I already put the vertex, 0, 5. So let's go up from 0. So the input's going to be 1, okay? Now, the output is going to be 1 times 1 minus 5. Now, notice how Desmos does the work for you. I mean, I didn't want to show you this, but it does. Or you could say this answer should be -4. So I'd like you to erase that and put -4. So if you put it on the wrong spot, the dot won't land on the graph. So the next one's going to be 2. So it's going to be 2 times 2 minus 5. And where am I getting the data? From the function up here. This says f says square it and then subtract 5. So what is 2 times 2 minus 5? That'd be negative 1. So can you guys go ahead and finish these and then do the ones in the bottom, okay? And would you have to do both sides, or would you... Say again? So for 3, I'm going to put 3 inside the x's, right? So it's going to be 3 times 3 minus 5. And you see how it puts the point over here perfectly? But I want you to actually do the math, which would be 9. 9 minus 5 is actually 4, right? And what's above 3?
4.
4. So then you're going to do 4 times 4 minus 5. So that'll be 16 minus 5 is 9, right? Oops. Wait, I made a mistake. Look, see my dot is not on the line? So I made a mistake because 16 minus 5 is not 9. It's actually 11. So if you make a mistake, your dot won't be on the right spot, okay? Now, on the left side over here, would I have to do the math again, or can I just copy these numbers? What do you think? Anybody have any idea?
You just copy the numbers?
Just copy the numbers, yeah. As long as you know that the vertex is this number right here, 0, negative 5. Actually, I'm in the bottom. I'm going to put 0, comma, negative 5. And I'm going to put a label. And can you guys try that out and put vertex? So underneath, make a new one. And this way it'll label it. And then this one is going to be negative 2. Now I'm really lazy, but if I know that it's going to give me the same answer as positive 2, I can just put negative 1. And it did work. See, it landed right on it. So I'm not trying to teach you guys to be lazy. I'm trying to teach you how to be efficient, all right?
When I type my PIN, it doesn't give me any dots.
Make sure you have the X and the Y.
Okay.
All right. So you have to replace the X. I think I forgot one. That'd be negative 4. And so you erase this thing where it says down 4. I just wrote that, but you can erase the whole thing and put negative 2. And then the next one would be negative 1.
I got it.
Yeah.
Oh, okay.
And then go ahead and do one more. And then this would be positive 4. And then do one more so I can have a mirror. And that would be negative 4. And that would be, instead of doing negative 4 times negative 4, which I could also do, negative 4 times negative 4, which equals also 16. And 16 minus 5 is 11. All right. Next, I'd like you to draw the axis of symmetry. And I'd like to offer 1,000,000 points if you can write an equation down here that draws a vertical line that goes right through the axis of symmetry. Can you guys try it out? So it's going to draw a line up and down right through this vertex. What would that be? I'll give you a hint. It's either, what is it?
Would it be like 0, 0?
X equals 0. X equals 0. There it is. Yep. It was 0, 0, Armand. It actually, 0, 0 would be a point, right? But I want a line, right, to go through that point. And this line, I'd like you to hold this little color for like a second, and then you can choose dashed or dotted, whatever you like. And that's your axis of symmetry. Now, I don't know how to label it, you know. All right, next. What is one of the x-intercepts? Can you guys click on one of them? It's kind of hard to tell, but you're going to have to like click right there. So that coordinate, you're going to have to write it over here in parentheses. Oh, I forgot what number it was. Can you guys tell me what the number was? It was 2 point something, wasn't it? What was that coordinate right where?
It was like 2.23 something.
Yeah, 236. Yep. So put 2.23 3, 6, comma 0. Oops, I forgot the 2. Now, in here in label, you could say a n, or you could call it x intercept. Well, one of the x intercepts. And why did I say it's one of the x intercepts? Well, there must be another one too, right? And that would be over where? Over here. And that coordinate is probably the same but negative. Okay, so go ahead and do that little piece, and then it's going to be negative 2.236 comma 0, and then for label put other. Okay, you can put x int. Okay, all right. And the last thing that we need is the y-intercept. By the way, can you have more than y-intercept for parabolas?
Yes. No.
No, right? See, if it's a U-ish shape, you can't the parabola can't turn around and hit the y again, right? It can only hit it one time. So in order for it to hit it twice, it would have to like go around, and then it wouldn't be a function anymore. So for y-intercept, there's always only one. And what is the y-intercept for this equation? Where does the graph hit the y-axis? And by the way, the y-intercept, the x is always 0. I think I threw myself off. In the y-intercept, the x is 0. So what is the y when x is 0? So look at the graph up and down on the x-axis, and look where the red, where's the graph at? Right where?
5.
Right there. Yep. And it's this one's -5, right? Perfect. And this would be the y-intercept also. Okay, cool. So this graph is actually exactly like the first graph that you guys did, except it's down 5. Let me see. Where's my function? Sorry, guys, I have too many tabs. Is it this one? Is it this one? Oops. All right. So let me go to your guys' work. Number 2. Okay. So here we are. I see everybody did that. So this graph is exactly like the previous graph, but it just got dropped down. It's called a vertical drop, vertical shift down. And you can almost see the function yelling at you, saying that it is. So if you go to the function, it looks like I closed it or something. Oh, here we go. So this function right here, if you read it, it says, let me open up Hannah's. It says, yo, Freddy is actually x squared. And x squared is the original function, the main generic boring one. It says, and then subtract 5 from all of the y's. So all of these numbers were actually 5 less than the other one. If you look at the data right here, all of these numbers, if you drop these numbers by 5, you would get all of these numbers right here. Would you guys agree with that?
Yes.
Yeah. Okay. So I don't know about you, but I'm really lazy. If I had already done the work for the first one, and then it says drop 5 from whatever you did before, well, then I would just go look at my answers and just drop them all 5. Okay. So what if it said plus 5? All right. So if it said plus 5, you would add 5 to all of the x's. Excuse me, the y's. Okay. All right, let's go to the third screen. All right, this function looks different because we're not doing x times x. Well, we are doing x times x, but we're going to add something to x first and then subtract something from x. And then we're going to multiply them both together, okay? So first, let's be tricky about this. Let's be sneaky. Let's go find out the, oh, hold on. Let me, can you guys all move to the next one? And I'm going to put you guys, I'll force you guys all in and watch this. Everybody will go to screen 3, okay? So on this one, let's be like clever about this. Let's find out what the vertex is, because I like to do only the work to the right of it. And what is the vertex? And it was -1, -9, if I remember correctly. Okay. So wouldn't you agree that if you do the work to the right of it, then you can just copy the same outputs and just copy them on the left side? Okay. So I'm going to go, let's see. Let's go 4, 3, 2, 1, 0, -1. Now I know it's hard for you because you're seeing your own screen and then you got to see my screen. So let me just start this off and then I'll let you guys. So I know the vertex is going to be at -1, -9. And then I'm going to do the work above it and then copy all of my answers below it. Okay. So the first one, I got to plug in a 1 to the x's. So I'm going to do, I'm sorry, I actually got to plug in 0. So I'm going to put 0 plus 4 times 0 minus 2. So what is 4 times -2? Everybody? 4 times -2 is -8. So then you can erase this work and put -8. Now, the next one, I'm going to put 1 for the x. So it's going to say 1 plus 4 times 1 minus 2. So then you're going to do 4 plus 1 is 5. So this becomes a 5. And what's 1 minus 2? That'll be -1. So what is 5 times -1? -5. Okay, so now I want you guys to do the rest.
I have a question.
Yeah, go for it.
So for the x point, so you put from like +4 to -2. Is that because the highest number in the equation is 4 and the lowest is -2?
Well, good question. I really appreciate that. So I was sneaky. I went to the vertex and I said, this is -1, right? -1. So I went 4 to the right of it and 4 to the left of it. So here's -1. And I went 1, 2, 3. I actually went 5 up, right? And I'm going to go what? 5 down from -1. And Armand, why do you think I'm doing that? Why do you think I'm going 5 up and 5 down from the vertex?
I have no idea.
Okay, so this is this is where the right here is where the graph bends, right? Where the parabola bends and turns back up. So I'm really lazy. If I know that it bends right here, I can just do these answers and then copy these answers where? To the left side. Does that make sense? So if you know the vertex is right here at -1, right? And if you went up to the right and you got this answer, wouldn't this answer over here be the same? Let me see if I can do a. There we go.
Yes.
Yeah, so that's why I'm being sneaky, right? So this is the vertex. So I'm just gonna go up 5 from there, and I'm gonna copy these answers. Watch. -8, -5. And do you see my copies over here? So I'm going to go to 2, right? And I'm going to plug in 2 here. What's 2 plus 4? Okay.
6.
And then times. And what's 2 minus 2?
0.
0. And what's 0 times 6?
0.
0. Cool. Look, it worked. Now, can I copy this 0 on the next one way down here? Okay. And what's the next one? 3. Ready? 3 plus 4, 7 times, right? 3 minus 2, 1. 7 times 1 is 7. And wouldn't I just copy this 7 where? Down there. Okay. So try it out, guys. I'll wait for you while you get these coordinates. Okay. Now, eventually, you're going to be graphing this without the decimals, but you'll be able to use this technique, right? Let me see. Go ahead and try it. I'm going to see what you guys, see your guys' work. Okay. All right. Nathan's going there. Okay. All right. Hannah's copying that. Klein is done. All right, Leah, good job. Okay. And Hayden, good job. Sophia's copying those. Brianna. Van, good job. So now I'm not trying to teach you guys how to be sneaky about this. I'm trying to teach you how to be clever about this, right? If you know a parabola is symmetrical, why do both sides of the work? Okay. Make sense? Now the key is knowing the vertex, right? No, that's the most important thing. Because if you don't know where the vertex is, then you don't know where to stop. Okay. All right, let me do an overlay.
The next question.
All right, you want to start the next question? Let's go. All right, let's go to the next question. Okay. All right, so here's the next question. And we're just going to stop at 7. There's not going to be any extra work for this today. It's just going to be just this. Okay. I'll know if you finished. All right, this one, I threw a negative in there just to mess with you. Okay. Now this one, let's be sneaky again. What is the vertex, Armand? Armand, are you with us? Are you Instagramming? Okay. The vertex is 0, -5. So I'm going to be sneaky. I'm only going to do the right side of 0, and then I'm going to copy the left side. So on my table, I'm going to add 5 to 0. I'll start 5, 4, 3, 2, 1, and then 0. Okay. And then I'm going to copy from here down. They're going to be copies, right? And I'll do here first. So if you put 0 here, so it's going to be negative. And everybody type it the long way for now, okay? Let's put negative. This is the long way to do it, okay? So what's 0 times 0? 0. 0, -0, 0. So the answer is -5. Perfect. Now, and if you want, on this one, put negative and then 1 times 1 and then -5. Okay. And go ahead and let the computer do all the work. So just put the parentheses. Don't worry about getting the exact one. Okay. Just let it do its thing. So let Desmos calculate it for you. Okay. Notice how there's only one negative. So this
I
one,
have a question.
this one would be wrong right there. Go ahead.
So I'm still confused on how you get the X points.
Oh,
So
the
like
X.
5, 4, 3.
Right. So since I was being sneaky, I looked at the graph right here, and I noticed that the top of it, the very peak, was 0, what? 0, -5, right? So what input caused the graph to go to the top? 0. 0 caused the graph to go to the very top, right? So I went from 0. This is going to be my vertex, and I went 5 above, right? And then what am I going to do? Again, 5 what? Below.
5 below.
Yeah. So number 3 is wrong. And why is number 3 wrong? Why am I not typing it right?
Because 3 isn't a negative?
Yeah, exactly. Because it should be like this. Okay. There we go. And I think in Desmos, you don't need the times. If you put two things that are multiplying with parentheses, it'll do it. Okay. Now, I know this is the long way to do it, and there is a reason why I'm having you do it the long way, okay? Because I've taught this class many, many times, and I know where students get confused, so I'm trying to prevent that, okay? All right, now we're going to copy the answers down here. So -1. So instead of putting the work, I'm going to go in sneaky, and I'm going to click on it. That answer was -6. Now, on this one, I want you to write the whole thing. Negative times -2. We already know the answer, right? But I want you to see, this is how you would do it manually. And how many negatives are there? There's so many negatives that we're going to like trip on our own feet. Look at it. It's negative, because that's what the equation said. Then -2 times -2 minus 5. There's so many negatives here that this is where students make mistakes right here, okay? But we know the answer should be the same answer as +2, which was -9. Okay, so go ahead and write the whole thing out. Okay, even though we know the answer, but just for practice, right? So we're gonna put negative parentheses -3 parentheses -3 parentheses -5. And then I'm just gonna go 2 more all the way down to -5. Negative. This is kind of boring, but oops, I made a mistake. Oh, another mistake. Gotta close the parentheses. And then -5. Okay. And last one for me, -5. Okay. Oops. All right. There we go. All right, let me see you guys' work.
So basically, do you just from the vertex you go however much up and then however much down?
Exactly, right? From the vertex. Cool. And why do we do that? Why do you think we do that?
Because the vertex is the lowest or highest.
Yeah, the lowest, yeah. So the work that you're gonna do for the right side will give you the same answers to the left side, right? Does that make sense? So, I mean, you could do both works if you like. If you like doing more work, go for it, right? But if you do the work on the left side, you can just copy that work and it's the same as on the right side. But the most important point, in my opinion, is the vertex. Because if you get the vertex wrong, then you're not really folding the parabola in half, okay? All right, last question I have for you guys is, and by the way, I did an overlay. That means this is everybody's work. So some of you, one of you has 3 dots that are horizontal, okay? And I don't want to, and maybe it's me again, right? Yeah, so Shiv right there, okay? So Shiv, let me see what you got here. Oh, yeah, Shiv, get rid of the -30 minus that. Okay, and I think you'll get that figured out. Okay. All right, and let's move to the next one. Oh, real quick before I move on, it's upside down, right? Or if you want to call it that way. And what makes it upside down? Look at the function. What makes it upside down? And what makes it upside down is kind of waiting for you guys, but
the -5 and then the -x.
Well, let's see. If you get rid of the first -5, it's actually not upside down, right? So which one does make it upside down?
The -5.
Oh, yeah, only the first negative, right? Yeah, this little negative right in the front. Can you guys try it with yours? Get rid of the negative in front of x squared. That's what makes it upside down. The second negative doesn't make it upside down. The -5, that just drops it down. So the first negative. So if there's a negative in front of x squared, it's going to be upside down. Okay, can you write that in your guys' notes right there? let me go to my notes. That'll be an important thing. Okay, let me go to. All right, upside down. If there's a negative in front of x squared, so if you have negative x squared, this will be upside down. Okay. In front of x squared. That's the important thing. Okay. And the reason is when you square something, it's going to turn positive, but this negative is always going to make your answer be negative. Okay. So any negative number squared will equal positive. Right?
Are we gonna have to still turn in pictures of these notes because there's not very much like written stuff?
Yeah. No, it's fine. What I want you to do is what I'm going to give you guys score on is you know what I'll do? I'll give you guys extra credit for the notes. Okay. For today. All right. So let's go to this one so we can finish this off. All right. So the next one is screen 3 or 5. And this one, there is a 0.5. So 0.5, that's positive. So the graph's going to be regular, right? The regular parabola. All right. So let's go ahead and find the vertex. Let's be sneaky about this. Can you guys find the vertex? What is it? What number is the vertex? -6. Okay, perfect. So go ahead and put. Now let's add only 4 to -6. So -6, -5, -4, -3, -2. So I'm gonna start at -2, -1. Whoops, hold up. -3, -3, -4, -5, and -6. And here is my work. And then I'm going to get these answers and then copy them and put them on the bottom, right? And what was the y? What was the output at -6? What is it? -18. Okay. All right. So now we got to put -5 into the function. So let's let our calculator do the work. -5, and you can square it, or you can just put -5 again. Okay, and then plus 6 times -5. And you can actually click on it and it'll give you the output. That'll be -17.5. -17.5. All right, and then the next one, go ahead and do that and just change it to 4. I did a copy and paste, by the way. And then I could just change the x's. And I'm going to click on the dot, and that one's -16. And then the next one, I'm going to do the same. I'm going to copy and paste it and just change all of the inputs to -3, -3, and then -3. And then I'm going to cheat a little bit, and that's going to be -13.5. And I just got one more to do. I don't know. Okay. All right. And then this one, I'm going to change this to -2, -2, -2. And then I'm going to cheat a little bit. And that one's going to be -10. So now, since I got all this work, can I just copy all these numbers underneath in the order? And then think I got. All right, and I'm there. So I'm able to do plenty of points. All right, let me take a peek to see what you guys are doing. By the way, if you're done or when you're done, can you do the axis of symmetry, the vertex, the x-intercepts, and label everything? And to label them, you go underneath and type a parenthesis. I'll do one of them. The vertex would be -6, comma, -18, and then type vertex. And axis of symmetry, what is the equation for the axis of symmetry? Can you guys shout that out if you can? What line, vertical line, will cross the the vertex? What would that be? Any ideas?
Can you repeat the question?
Yeah, the question is, what line will? Here's a vertical line. Can you tell me the equation of this green line that will actually be at the middle of the parabola?
X equals -6.
There you go. And do you notice that the vertex, the x of the vertex tells you the axis of symmetry? And make your axis of symmetry dashed. Okay. There it is. So the axis of symmetry equation is kind of weird. It's just x equals a number, and it actually draws a line. And the reason is it's actually plus 0y, but the y doesn't do anything. It's being multiplied by 0. Okay, so that's the x symmetry. What is one of the x-intercepts? What is one of the x-intercepts? And we're going to actually stop with 5. We're not going to do 6 and 7, but I want to do everything on screen 5. Can somebody tell me what is one of my x-intercepts? And by the way, I know that the y is always 0. So all I need is the x of the x-intercept. What is one of the x-intercepts? And you can click on it. Right?
-12.
-12. Yep. And that would be -12, comma 0, right? So -12, comma 0, and then put a x-int. Okay. And what is the other x-intercept?
0.
0 what? 0, comma 0. Yeah, so remember, intercepts, you got to give me the x and the y. Now, the x-intercept, you already know the half of the answer. The y is 0. You got to just give me the x-intercept, number 2, right? All right, and last one. What is the y-intercept?
-6, 0.
-6, 0. Let's try that. Let's try. Does that dot hit? So the question is, where does this red parabola hit the y-axis?
Oh, at
So that y-axis is right here, right? This black line. So where?
So it's at 0.
It's also a 0, 0. So sometimes the x-intercept and the y-intercept are the same, right? Sometimes. All right. So I think we got everything. We got the vertex, we got the x-intercepts, and we have some points. So in this topic, we're going to take our time. There's a lot to it, but we're going to go really slow and easy. So I'm teaching you guys my very lazy method of doing parabolas. I did this when I was a kid, and I would be done with these really fast, and my friends would be doing all kinds of calculations. I'm like, wait, but they're the same on the other side. And guess what they would start their tables? They would start their tables at 5 to -5. And would that be a good place to start for this equation, for this function? They went from 5 to -5. Would you catch the vertex between these numbers? No, the vertex would happen actually at -6. So they would do all this work, and their parabola would only look like the top part. Okay. All right. Now, what do you think this 0.5 did to the work, to the function? Let's get rid of the 0.5 and look at the difference. So what did the 0.5 do? Did it move it? Did it stretch it? Did it shift it? What do you think it did?
It moved it.
It moved it a lot, right? Like
Yeah.
a ton. So it's really hard to know like what these numbers do. 0.5. Now, get rid of the 6 only. What did the 6 do? What did the 6 do? Did it also move it? Okay. All right. And this is the last thing. Okay. And then we'll be done for today. And we'll have a good weekend. From the vertex, remember yesterday we said everything goes up by 1, 3, 5, 7. Give me a shout out if you remember that. It goes up 1, 3, 5, 7.
I remember.
Yep. Okay. Now this one, if you look at the vertex, this one only went up 50 cents. 0.5. And then it went up $1.50, 150. And then it went 250. And then 350. And I'm going to write this down so you guys can see. I think we call it the quadratic slope. And go ahead and write this down on your notes. Okay. Normal quadratic slope. From vertex, right? What's the most important point that I like? From vertex.
0.
Yeah, but which one? Look at this one. That's my favorite input, right? My vertex. So it's gonna go up 1 over 1. Up 3 over what? 1. Up 5. 1, 2, 3, 4, 5 over 1. Okay. So the slope is 1 over 1, 3 over 1, 5 over 1, 7 over 1, 9 over 1, ... right? What did this one do for x squared, right? What did this one do to the slope? What did this half do? Instead of going up, it went half of 1 over 1, which is 0.5, right? Let me erase that. So you cut them all in half. So what's half of 1? Half. What's half of 3? What's half of 5? What's half of 7? What's half of 9? So this would be the new slope, the slope for this equation. So the number in front of x squared will mess with our slope pattern. It'll half it. And here is for extra credit. What do you think this 3 will do for our slope? Can somebody think about that and shout it out? What do you think this 3 will do to our slope?
Make it steeper.
Make it steeper. How much steeper do you think?
A lot steeper, probably.
A lot.
Probably
3 times steeper. 3 times steeper. So the first, I like the word steeper. The first step, instead of 3, instead of 1, it's going to go what? 3. What's the next step going to do? It's not going to be 3. It's going to be what?
9.
9. And the next step is going to be what?
81.
3 times. Oh, careful. It's not 3. It's 3 times 5 is what? Does that make sense? And then the next one, you're going to multiply 7. So each step is going to get really, really tall. The first step is going to go up 3 over 1. The next step is going to be up 9 over 1. Okay. And I'm going to give you guys extra credit if you show me this, right? And in decimals, just watch this and I'll show you what I'm talking about. And this is why quadratics are so simple to me. And to my friends, they weren't simple, but I was like, oh, it's deeper. Watch. All right, so the first one, and I'm going to go to the table instead, okay? So look at this. From 0, 0, it went up 3. Can't zoom in. And from 3 to 12, it went up 9. And what do you think the next one's going to go up by? Look at that. That's 15. And the next one is going to go 21. And these numbers are the same numbers we got right here. So it went up 3, it went up 9, it went up 15. Now remember, the steps are always one foot. Think about the steps in your house are always the size of your foot. But the steps get taller and taller and taller. Okay? All right, guys. So that's all for today. All right. So I will be getting your guys' scores from here. So if you were here with us from the Desmos, so make sure if you're watching this on the recording, you got to get to screen 5, and I'll be able to know who did this work. And then lastly, if you post your notes, I'll give you guys extra credit, especially if you give me that the slope gets 3 times bigger. Okay. All right. Any questions on?
We don't have to do number 6 and 7, or do we?
No, it's fine. I'm gonna unlock it so you guys can see, but it's pretty much the same, you know.
Okay, we're putting credit on it, right?
Yeah, no, I'm just gonna grade to 5 because it gets a little bit repetitive. Okay.
Okay.
And that's okay to be repetitive. It's just that for today is Friday, and I think we'll be okay. Okay. So I'll be giving you guys, especially everybody that was here. But if you're watching this on the recording, you make sure to get to screen 5, and I'll be able to see from here. Look at this. Let me stop this pacing. This is how I'm going to get your guys' scores, right? I click on summary, and it shows me right here. Okay. So if you can make sure to have a great weekend, and then we'll start Monday, and I'll see you guys then. All right. Bye, everybody.
Bye.
Bye.
Bye. Bye. Have a good weekend.